Hey, in this tutorial, you'll learn how to scrape and crawl data from the internet and use the data to fine-tune a large language model, tailoring it to your use case. We'll fine-tune an LLM to classify articles into news categories like politics, business, climate, and more. We'll switch the LLM's function from text generation to text classification so it can automatically assign the correct category to news articles based on their content. While we're focusing on classification for its simplicity and its wide-range usage, you can follow the same fine-tuning workflow for other tasks, whether it's instruction tuning, text generation, summarization, or beyond, by simply swapping out the training objective. I'll teach you how to gather and scrape a domain-specific dataset from the internet using Decodo. Then, we'll dive into the fundamentals of large language models and fine-tuning so you fully understand what you're building. We'll then prepare the gathered dataset for training by cleaning and wrangling it. Two essential steps in any machine learning workflow. Finally, we'll train and evaluate a large language model called LLaMA using Hugging Face, one of the most popular libraries for working with AI models. While we demonstrate this process with LLaMA, you're free to swap in any other Hugging Face model you prefer. Hugging Face provides a wide range of open-source models along with their user-friendly tools to make it easy to load, train, fine-tune, and evaluate AI models. To make the data gathering super easy, we're teaming up with Decodo. They're offering free trials so you can follow along completely for free. Decodo makes web scraping a breeze. With its intuitive APIs, built-in JavaScript rendering, and automatic proxy rotation, you won't have to worry about getting blocked when scraping data. They also have ethically sourced IPs and proxies that are very convenient to use. So make sure to check them out in the description below. So, if you're a beginner or an experienced machine learning engineer, this tutorial will add essential skills for the job market in your CV. So, let's get started. So we'll be creating an AI that is able to take in an article like those and predict one of those categories right there: politics, business, health, science, and climate. And it will take in just the text. So if you opened one of those articles, it will take this text here of the article and it will produce the category of it. So you have the politics category, you have the business category, you have the health, depending on what the article is talking about. And categorizing articles into different classes has a lot of real-world use cases for that, one of which is that instead of manually selecting which article belongs to which category, you can automatically do it. And the second thing is that you can use those categories for advertisement placements and optimizing ads. And the third thing is you can also utilize it for recommendation engines. So when you're reading an article, you can automatically get recommended different articles in the same category. So in here, you have different categories like those, and we'll be choosing politics, business, health, science, and climate. We'll be choosing those 5 categories. And for example, if you clicked on health, you're going to see a lot of health articles like those. And when you scroll down, you're going to see load more stories. You can click on it and you can load more stories. So what we are going to do is that we need to understand that those are health articles. So we already have this link that tells us that those are health. And then we'll be looping over each one of those articles right there. And we'll be opening it right here. We'll be scraping the text and then matching it to health. So this is going to be our dataset basically. We're going to loop over each of those articles, open them one by one till we gather enough data. So head over to Decodo.com and Decodo is going to help us to scrape the website without fearing of getting blocked or doing exponential backoffs or like sleeping between scrapes. It's going to help us like simplify the scraping process a lot, and we will not get blocked because of its awesome features. So you can go ahead and create a free account. You can log in with your Gmail or just email and password. Decodo offers a lot of proxy and IP solutions where you can access the internet through those proxies and IPs, and those link to real-world data centers and residential IPs, so you don't need to worry about getting blocked or getting backed off, and you can just access the internet through those. So one of the APIs that we are going to use is the scraping API that makes it super convenient for us to scrape any website that we want. And if you can go to the API playground, you have two options, core and advanced. Advanced basically gives you the ability to set the location, the language, the browser even. And it also has the feature to do JavaScript rendering, which is very convenient for us for JavaScript websites. And we also have the core API that doesn't give us much control, but it also works good. So all that you have to do is give the URL and do a post request, and you can just send it here. Right here, we're trying to crawl the ip.decodo.com, and you can see the website right here crawled as HTML, and you can also check its live preview. Now, you can also go to the NPR right there. Like this website, go to the homepage, for example, and then you can go here. You can replace the URL and send the request again. And you can see here that it crawled the website, and you can see its live preview right there. So we successfully crawled it quite easily. And again, we will crawl as much as we want, as fast as we want it, because we won't be fearing about getting blocked. So we can start by enabling for us the scraping API, and we can use only the core. We won't need the advanced here, but feel free to play around with it if you want. So in order for us to get started, we can go to pricing, and we'll make this tutorial free for everyone. So you have the start with the free trial. So you can press on it, and it gives you 7 days free trial with 1,000 requests that you can play around with. And it's going to be more than enough for us to scrape 500 articles, 100 per each category that we chose. And 100 categories is not enough to get very high accuracy levels, but it's going to be within our free range to play around with, and you're gonna get a feeling about how you can do this LLM. And to just increase the accuracy, you just increase the number of articles, and that's it. So you can go ahead and check out. Again, it's free, it's $0. And you're going to find here that the core API is enabled for you. So make sure that you check out on the core API, not the advanced. But if you checked out on the advanced, that's fine too. But the core is going to be good enough for us. And once you check out, you're going to find here another tab with the core API. I'm going to check out and then come back to you. So after checking out, I already also played with it a little bit. So you can see here that how many requests did you use for your free trial. I used 824. And you should find 0. You shouldn't have used anything right now. But you also will find another tab right there that is called Web Core. So click on it. And you're going to find an example request that you can give it the URL that you want to crawl, and it will crawl it for you. So if you just send the request, you're going to see the HTML, and you can also see the live preview. So this is the curl command that you can paste into your terminal. But if you want to have Python code, you just have this option right there. So this is the Python code that you're going to use if you want to crawl this website in Python. So you can just copy it, and then we'll paste it in. So one of the easiest ways that we can play around with Python is to use Google Colab, and it's just a notebook, a Python notebook in the browser, so that we can play around with. So you can just have this Google Colab, search on it, you're gonna find it right there, right here, and we are going to create a new notebook. You might find a different setup for you because I used Google Colab before. And yeah, just create a new notebook right there, and we can call it Web Scraping for LLM Fine Tuning. Like that. And the first thing that we are going to do is just paste in the code that we have just copied. So it imports requests, and request is just making a request to a server, and this is how you do it in Python. So this is the server that we are going to request it from, and in its payload, in its parameters that we want to give it to, we want to say that please scrape this website. And then there are multiple headers right there, and this header is telling you who you are, so it can check your credit and make sure that you have enough credit so that it can respond to you back. So yeah, this is basically it. So you can go ahead and run it and see how it goes. So you here see that here's the text, here's the HTML of the page. We're going to go over the HTML of the page, and I will also refresh you about what HTML is and what elements do we want to focus on, and we'll do that very soon. So this is it. This is how you crawl a website. We just give it the URL. We specify the token that indicates that this is our account, and yeah, this is the endpoint that basically scrapes the website for us. This is as easy as it gets. So in order for us to create a new function that crawls any URL that we give it, so you can have the URL to crawl like that, and you just can copy paste it right here like this, and instead of having a hard-coded URL, you can just take it as a parameter, and we can just return back the response. And this is how you create a function to crawl any website that you throw at it. So yeah, this is it, and in the response you're going to also find something that is called status code, and status code is indicating whether it is successful or not. 200 is successful, 404 is not found, like 500 there's an error. There are multiple status code, but just check that it's 200 to make sure that it was crawled successfully. So before we proceed any further, I will go ahead and have an HTML refresher. So if you have the HTML basics, just skip this section, but this is going to be just to onboard you on what are HTML tags and what are some tags that we are going to use for crawling this website. So yeah, I'm going to do this in like 10 minutes, so it's not going to take a long time. So we can go ahead and create a new folder right here. Call it HTML basics, and inside of here you can open up whatever text editor you want or code editor you want. So I'm going to open up Visual Studio Code, but feel free to open up whatever you have, and we can create a new file called example HTML.html. You can call it whatever you want, but just have the HTML extension to say that this is an HTML file or a web page. So HTML is hypertext markup language that is basically telling the browser what to display and how to structure it. So it's as simple as that. So if you want to display some text, like let's say hello world, you can save it, and you're gonna find that this HTML page is going to have the hello world. So now we have a full website that has hello world right there. But HTML also structures data, so we can also have something like an H1 tag. H1 is a heading 1, so if you opened up, for example, Word or Google Docs, you can have the option to make the heading 1 as a text, and this is basically a big text. So this is a big text that is going to be the header of the website. So if you refreshed it, you're going to see that it's now a big and bold text. We also have a paragraph tag, and we can have, this is a paragraph, so you can like refresh it right there, and this is another paragraph right there. And HTML usually have an opening tag and a closing tag, and this indicates that anything between those tags is going to is going to have this tag applied to it. So hello world is between the h1 tag, so it's big and bold, but the paragraph tag is but this is a paragraph is between the paragraph tag, and this is going to be less bold and less big. Now that we learned two tags of the HTML, which is the h1 tag and the paragraph tag, we also have the HTML tag. So the HTML tag basically indicates that anything between this HTML tag is HTML code, and this is just best practice, and you can just save it, refresh the screen, you're going to see that everything here is the same. But this is best practice. Also, another best practice is to specify the doc type. So we can specify that this is the doc type of HTML, to specify that this file is HTML. And we can also specify the header. So you can right now here see that this has like this header right now has the same name as our file name. So if you want to change it, you can just have the header and title, and then you can call this my first page. You can save it, and you can save it right there. You can see that this is my first page. So this is basically it, like a couple of tags that is indicating to the user or to the browser, sorry, that this text is having this specific functionality. And the other thing that we also have is the body tag. And the body tag basically indicates for us that this is the body of the website. So this was the head, which is right there. And this is the body of it. And yeah, it shouldn't change anything right here. So when you refresh it, everything stays the same. So our next tag to learn is called the anchor tag, and the anchor tag is just the link tags that you can see in websites. So for example, you can see that this, when I hover on it, it makes a pointer, and when I click on it, it takes me to another screen. So this is what we call the anchor tag. It's the clickable text. So anchor tag does have two things, which is the text inside. We can make it whatever text we want. Just like we made hello world for h1, you can make this the Google link or whatever text you want. But inside of it, you have another attribute, which is called the href. Href is basically going to tell us when we click on the Google link, it will take us to this exact website. So you can just save it and come back here and refresh it. You're going to find the Google link, and if you clicked on it, it's going to take you to Google. Press back to go back to your home, to go back to your HTML page, and we can continue. Another tag that we have is called a div. And div is just a container containing other HTML tags. So for example, this is a div. This is a this is the heading 2, which is h2. We have h1, h2 till h6, I guess. But basically, each one has a smaller font and a smaller font size and less bold, basically. And div right here doesn't do anything except to structure the data inside. So it's structuring our code, and it's not doing anything to the browser. So if you clicked on it, it's going to be the exact same thing as without a div. And I'll press back. So this is the div. It's just a container containing other parts of the code, and it's going to be easier for us to refer to this div so that we can apply like styles to it, apply some logic to it, and this is why divs are used. It's just for structuring purposes and to like refer to it. So for example, I can go here and I can apply some styles to it. Those styles are going to be CSS styles, so you can just ignore it for now. It's not going to be used for crawling much. But right here, you can say that any div, we want to have the color of red. So let's spell color correctly, and it's going to be red. And before running it, just remove the dot and just save it. Go back here and refresh it. You can see that we were now able to refer to this exact div and tell that in anything that is inside this div, make it in red. So those are what divs are used for. It's basically for structuring and being able to refer to specific parts of the HTML page and applying some styles and some logic to it. We can have another div right there, and we can call this div2 and add 2 here as well. And yeah, we can also refresh it. You can see that every div has the red applied to it. But what if we want to refer to a specific div, like the div1, but not div2? And this is where classes and IDs come in. So you can have a class that is called ID1, and class is just an identifier that tells the styles and tells the logic which part of the code that we want to apply those styles to. And we can refer to classes by just adding a dot and then writing the class name. The class name right here is called div1, and I can call it section, for example, 1, to not have any confusion with divs. So we can have it section 1, you can save it, and you can come back here. You can see that this is in red. Now, another way that we can refer to divs is with an ID. So an ID of, let's call this section 2. And the difference between a class and ID is that a class, you can have a class to different divs. So this div and div3, for example, can have this the same class. So section 1, and we can have this as like this. So it has like both divs here have the same class, and it will have the same styles applied to them. But div2 is only going to have an ID, and an ID you can apply to only one, basically one tag. We will not be able to copy paste it into other parts as well. So for the ID, we refer it with a hash like this, and we can make it the color of green. So you can come back here. You can see that this is colored green, and the other class is colored in red. Now you can go back here. You can see that this is the HTML that we are going to need. Again, we are going to have some H1s. Anchor tag is where you link other pages as well. Paragraph tags is where you have paragraph texts, and it's going to have the article inside. So this is going to be useful for us. Divs is going to be referring to specific sections of the page so that we can crawl those specific pages and take this exact place and not, for example, take like this. If we opened it, you can see that there's an advertisement website. There's an advertisement space. There is some recommendations, and we only want to take in, and we also have this. So we only want to take in the text and not take in the other components of this website. So we have the header, we have those search boxes and banner. So we don't want to take all that. We just want to take in this, and referring to the exact div is going to help us to just take in the text inside of it. And yeah, so this is it for the HTML refresher, and we can go back again to our Colab and then continue crawling our website. So go back again here. We now have the crawl function that we can give it whatever URL that we want to crawl, and then it responds back with the output HTML. So right now we just want to know which websites or which URLs that we want to crawl. So if you came here and you can go to, for example, politics. And now it has a lot of articles, and if you load more, it's going to load more articles like there. And yeah, in order for us to see the HTML of this page, you can right click if you have Chrome, and you can just press inspect. And you can see the, for example, the load more here and load more button. So if you clicked on it, when you click this tool and then you click on it, it's going to highlight the HTML of this. Again, you're going to see that it's very familiar. It's a div, and it's inside of it, it has a button. Although I didn't show you the button, we won't need to be crawling it, so that's why I didn't show you. But you can understand that the button is clickable and it does something as well. And yeah, when we press load more, it takes us to, it loads other data as well. So what you need to do is you need to go to network right there, and you can press load more. And you can see this next and start has been loaded. So you can just click on it, and it takes you to the other website. So basically, this is going to be the website where the ID here is the politics ID. And then it tells us that we need to starting from article number 49 till article and we load 24 articles. So basically, we can edit this URL as much as we want. We can say that let's start at the article number 1, and let's load only 10 articles. So let's load 10 and just have this. So you can see that those are the top 10 articles, and if we finish them, we can go ahead and make it starting from 11 till 20 and load it again. So this is a very convenient way for us to just keep looping on and just adding some numbers right there to the URL so that we can continue on loading more and more stories till we gather enough data that we want. So just copy this and we can just paste it right here. So we can delete this and we can delete the other part as well. And we can have a dictionary right there that is called URLs to crawl. And inside those URLs to crawl, we are going to have politics. And inside of this politics, we are going to paste in this URL that we just copied. And it has a start and the count. So basically just cut them out. And we are going to be adding them later on. So I'm going to keep a reference for it right there. But we are going to be adding them while we're looping. So we'll loop over from 1 to 10, then from 11 to 20, and so on and so forth. And yeah, basically we are going to have another one for business. We are going to have another one for health. Again, those IDs are going to be wrong and we need to get them. So I'm going to just fill out the all oral categories first, and then I will go ahead and get the correct ones. So you can get the climate, and yeah, those this is it. So you can go back to your NPR website, go back here, close that, and then you can go to business. Scroll down to load more, again right click, inspect, and then press on network and press on load more stories. You're gonna find this appears, just click on it, and like this it opens up this, and you're gonna find that this is the ID for the business. So you can just copy paste the whole URL. So go ahead here and copy paste the whole URL like this, and you're gonna see the only thing that is different between both is the ID. So you can do the same thing for health and you can do the same thing for science. So, but I'm going to make it easier for you, and you can just copy paste their IDs. Health is going to be 1128, and science is going to be 1007, and climate is going to be 1167. And this is it. So let's now take it step by step and crawl the first page in politics, for example. So let's now use our function that we have. So let's have this. So inside of this, we can have the category URL, and we are going to take in the politics. So you can just refer here to politics, and yeah, and we are going to have the start index of 1, and the batch size is going to be, for example, 10. We're just going to get some 10 articles. And in order for us to crawl this, we just have this right there, and we write the category URL followed by start, which is going to be equal to the start index, and then it's going to be followed by the batch size, which is going to be the count is equal to the batch size, and we are going to have the crawled page. Sorry about that. You need to run the first cell first. So run them before you run the crawl page. And now you have the page crawled. So if you print the crawled page, you're going to find that this is 200, so everything is good. You can also check the text, and everything here looks good. The page has been crawled, and you can see some HTML right there. Now, in order for us to only choose the HTML, you can see that this is a JSON file, but it's in text format. So in order for us to cast it to be a dictionary, you can just import JSON. We can have JSON.loads like this. And we can call this crawl page JSON. Now, in this crawl page JSON, we can just get the results like this. Again, this is the results, and inside of the results we have the content, which has the HTML page, but we also have the status code. So you can see that this is a list, so you can make it of 0, and then of status code like this, and the status code here is 200. So you can put it here in status code, make sure that everything is good. So if it's 200, then everything should be wonderful. So now we want to extract the HTML of the page. So you can write here the HTML string, and it's going to be the crawl page JSON. Actually, you can just copy paste this crawl page JSON of results of 0, but instead of status code, it's going to be content. Now, this is the HTML string. So you can just paste it out. You're going to see divs, you're going to see articles and things like that. So yeah, let's go ahead in this again and right click and inspect. So right here, we just want to see how this page is structured and how can we loop over each article so that we can get its links, and then we open each link to get the article text. So again, choose this tool and choose the article like this. And you're going to see that inside of the div, you're going to find another category called article. And inside of those articles, you're going to find multiple things. And one of them is the image, like this image. And then you're going to find the headline, the title, the things like that. But what we really want to focus on is this URL right there. Now this URL is important for us because if we opened it, it gets us to the actual article and we can just crawl the text. So the main reason that we crawl this website, crawl this page, is to actually loop over each article right here and to extract their URLs. So basically, I am going to choose this tool, highlight this, and see the URL right there. So you're gonna find that it is in a div, and each article is in the article tag, and the article tag right there is like a div. It's just a container, and right here you're gonna see the article tag, and inside of the article tag you're gonna find a lot of divs, but the second div right there has an anchor tag that we want to crawl. So that is what we're going to do basically, is that we're going to loop over each article and extract their anchor tags. That is it. So yeah, so that's it. So you can go back again to your code right here, and let's print out this HTML, and you can see here that if you scroll back up again, you're gonna find the article tag, you're gonna find a div, and if you looked hard enough, you're gonna also find the anchor tag. So here's the anchor tag of the first article, and yeah, what we can do is that this is right now is in string format, and strings are going to be harder for us to extract the href. Actually, you can also do it. You can try to do it yourself, but there's an easier way for us to do it, which is called Beautiful Soup. Now, Beautiful Soup reads in this HTML string and has a very convenient way of searching the string and extracting parts of the string that we want based on the tag. So I can tell it, hey, extract me all the articles that you see, and it will give it to me in a structured list. And then in each article, I can tell it, hey, extract the anchor tag that you see, the first anchor tag that you see, and it will return it back to me. So this is how simple Beautiful Soup makes things for us. So you can go back here, import from BS4, import Beautiful Soup. And if you want to run all those things locally, you feel free to do so. I'm just running it right here so that if someone doesn't have the Python environment, they can also follow along quite easily. So the Beautiful Soup right here, and what we want to do is we want to also give it the HTML string, and we want to tell it that use the HTML parser to parse this string like this. And we are going to call this soup like that. Now, I'm going to show you how easy it is to find the articles. I'm going to leave the HTML string right there so that we can refer to it. So you can have the soup dot find all, and this is going to find all whatever that we want to give it, and we are going to find all articles. So every tag that is going to have the article is going to be returned. So let's run it, and right now it returned back all the articles that it found. So if you can scroll back again up, you're gonna see that it's in a structured list. So you can see that this is the article, and inside of each article there is an href. So what we want to do is I want to show you how you can extract also this href. So you can have the article, actually, like, we can have for article, we can loop over it from for article in, and we can have this find all articles. And for each article, what we want to do is we want to extract the anchor tag. So we can have the anchor tag is equal to article.find and a. And find here is going to find the first anchor tag that it sees, and it's going to be this one. So let's print it out, and let's also break so that we don't have to loop over this again. So this is the extracted anchor tag of the first article. So because I am looping over each article, but I'm breaking from the first one. So yeah, we told it to extract the first anchor tag, and so it did. This is the first anchor tag, and this is where it's closed. Inside of it, there's a picture, and there's some other text as well. We don't care about all this, to be honest. So if we can see this, all this is clickable. Like, all this should be clickable right there. I can click on the image. I can click on anything right there. All this is within the anchor tag. And what I really want is this URL so that I can go crawl it. So what I want to do is that I can have I can just say that I just want the href, and you can just do this by having square bracket and tell it href. So you can print it out, and this is the article that was extracted. So you can just click on it, and it takes you to the article itself. So yeah, now we have the URL for the article, and guess what? We can now crawl it quite easily using the same crawl function. So in here, you can just crawl the same function. So the same function that we have, and we can give it the this URL basically. So I can just copy paste it and put it here, but I want to make it a little bit more structured. So I'm going to put it here in an article URL like this. I'm telling you the full cycle of it so that we can visualize how it's going to work, and then I'm going to clean the code with you. And then you can run it right there, and we can give it to the crawl function right here. The crawl function should be right here in the for loop so that it can crawl the URL and just extract the text. But I don't want to have it right here right now because we're still developing, and every time I run this for loop, it's going to go and crawl the website. While I don't want to do that, I just want to crawl it one time for now so that we can understand how it goes and understand the full structure of it, and then I can go ahead and clean the code with you guys. So in here you can have the crawled article like this, and inside of this crawled article you're gonna also find the same thing that we found with the other URL that we crawled, which is 200, and if you have the text, you're going to see also the HTML of it. So just like we did with the previous URL, we are going to convert that to JSON. So JSON.loads, which is a dictionary. Then we can call it crawled article JSON like this. We can also have a status code. We can see the status code of it. So again, of results of 0, of status code, and it's going to be 200. So so that looks good. And then we are going to also have the HTML string, and the HTML string here is going to be the crawled article JSON of content, and then we are going to want to make it into a soup. So right here we are going to convert it to a beautiful soup, and yeah, that is it. So right now we have the soup object with all the HTML that we want, and we can filter out the HTML based on what thing we want, what text we want. So basically, you can go ahead and press on any link to go to an article, and from here you can just press on this tool right here again, and you can see where is the text located in what div. So you can see here that this here div is the whole text, and it finishes when the text finishes, and you can like click on it, so you can see that this is div has an ID of story text, and we can extract all the text inside of it. So basically we choose this div with ID of story text and then extract all the text that is inside. So in order for us to do that, it's going to be super simple. We're going to find soup.find, and we want to find a div, but we want to specify the class of the div to be story text, and this is going to be the story div right there. And when we extract the story div, I want to show you also what's inside of it, and this is what's inside of the story div. right there, a lot of HTML, a lot of things like that. But what we want to extract is we want to extract the text. So you can have a function called getText, and in here we are going to strip is equal to true to strip any leading or trailing spaces, and we are going to have a separator of new line. So if there's a new line, it's going to be a separator. So let me run that for you, and you can see here that here is the text for the article. You're going to see that there's a lot of good text right there, and yeah, we can just put it as the article's text. Now this is it. This is the crawler basically, but the code is still very messy. But I want to go ahead and explain it to you since we did it step by step, and then we can clean it together. So the first step is to crawl one index page like this. So you crawl it, and you're gonna find that this page is loaded, and when it's crawled, you want to go through each link of those. You want to open it, so open that, and then you want to crawl this text. And yeah, this is basically it. We're going to do this for each URL that we want to crawl. So let's start by writing a function that takes in the URL for the article itself and then extract its text. So this is going to be a simple one, so a simpler one. So we're going to start off with that. So this is the code right there. This like till this. This is just the code to extract the text of the article. So let's have a function define get article text, and we are going to take in the article URL. And inside of here, we are going to have the crawl article, so just cut it. So like this. So now we crawled it. We can make it into JSON. And then we can check its status code and make sure that the status code is 200. If not, we can just skip it because there's a lot of fish in the sea, and we can crawl just another one. So status code like this, and if the status code is not equal to 200, then we can just skip it. So if it's not equal to 200, 200 means successful. If it's not successful, we can just skip it. So return none. So we just return none if it failed or if it wasn't successful, and we can just ignore the nones when we see it. Then what we want to do is we want to extract the HTML string and then convert it to a soup, beautiful soup object. So just have the HTML string right there that takes in the crawl JSON, and then we also do it as a soup. Then we want to extract the div that has the article text. So we can have here get article text, and then if this story div is not is none, basically it doesn't exist for some reason or another, we can just return none and we can just ignore it and move on to the next one. If not, then we are going to extract the text. So just extract the text and then return it. So this is basically it. This is how we can crawl an article, and just in case something crashes, something is weird in the website, so you can have the try and except. So try like this and accept and return none. So basically, if something goes wrong, if something breaks, if something does anything like that, we don't panic and we don't crash the code because we're crawling a lot of data. We don't want to have it pause at the middle. We just want it to continue. So if one article is buggy or something like that, we just want to make sure that it doesn't crash the code. So it tries it. If not, if it crashes or anything, it goes to the accept and it returns none. And if it returns none, we can just handle the none later on so that we can just ignore them and we don't take them into consideration. So yeah, Right now, I cut the function, I will paste it right there. This is the get URL function. Sorry, this is the get article text function. Basically, you give it the article URL and it returns back the full article text. Then the code that is left right there is basically looping over each of the articles that we have in our index page and returning back the anchor tags. So what we want to do is we want to have an iterator, for example, to just give us the next tag and next tag and next tag and next tag. So we just want to have a function that when we call it, it returns back the next tag to crawl, next anchor tag to crawl. And this is what we call an iterator function. It's going to encapsulate a lot of this logic. It's going to make it really easy for us, but I want to show you an iterator function first. So define, let's call it iterator like this. And basically, it's going to for I in range 10. It's going to have something called yield. Yield is just return, but it's not actually exiting the function. It's going to just return whatever we want. So it's returning I, and when we call it again, it's going to continue the function from there. So for example, this is returning, for example, like if I'm going to return I right there, it's going to just return 1. So for example, if I have an ITT like this, and we can print it. Again, this is going to, every time it's called, it returns 1. But when we change the return to yield, this becomes an iterator function, where the first time it's called, it's returning 0, but the second time it's being called, it will return 1, 2, 3, so on and so forth. It has a state stored where it knows where it stopped, and then when it's called back, it will continue on the loop from there. So that is what we want to do. We want to have an iterator function that knows where the last article was, and then it will continue on from there. So you can have, I can show you basically for I in ITT, and then we can go over them. So just run it again. So 0, 1, 2, 3 till 9. So this is what the iterator function is, and hopefully what we can do is that we can have something like that, but a little bit more complicated. So basically, have something like this, where every time it's being called, it's returning back an article URL. So let's try this out. Oh yeah, because the last soup function, the last soup object was not the index page. So let me crawl it again. So we can run this, and this again. And yeah, give it a little bit of time. So you can see right here, it returned this, all of them, all the anchor tags that we have. Now let's make this function a little bit also more robust and take in the parts of the code that is above it, so that we can make a good iterator function. So this is going to be called get next article. It's going to have the category URL as an input, and the batch size as also the input, but the batch size has a default of 10, so we can skip, like we don't need to give it to it. And the start index is going to start from 1. Then what we want to do is we want to get the crawl page like this, and we want to have while true. We want to keep on crawling till we find the maximum number of articles that we want. So while true, we crawl the page, and then we convert it to JSON, and then we want to check the status code. So right there, we can check if the status code is not equal to 200, then we can just break. because if we found something that is not equal to 200, maybe we just reached the limit of the website, so we can just break. Then it automatically completed that we need to also the HTML and soup, but we can just also, while we are cutting and pasting things, we can just cut it and paste it right there. So make sure to cut it and paste it. If it wasn't completed on your side, just cut it and paste it. And right after that, we want to loop over each article and find the anchor tag. And if the anchor tag was not found, so if anchor tag is none, basically we continue. We don't need this. We can take the next article, and then we can get the article text by calling our helper function, which is get article text, which what we called right there. So this is also getting the article text, and we are checking if article text is none, because you remember here, if anything breaks, we return none. So if article text is none, we continue. Else we return back the article text. So we yield article text. Now the last thing that I want to do here is I want to increment the start index. So the start index plus equals the batch size. And that is basically it. This is going to keep looping over the article category one by one till the website finishes, basically, till we finish the website. So we can just cut it. And again, don't worry about reaching, like we said, we want to crawl 100. So basically, we can break the loop whenever we want to, but I'm going to leave this right there so that we can be able to reuse it in other places as well. But while we're looping here over the iterator function, I can say that if we reached 100, then we can simply break. So just cut it, paste it right here, make sure to run it. Now we are almost done. So right now we just want to loop over each category. So for news category and category URL in URLs to crawl dot items, like this. And for each one of those, what we want to do is we want to print crawling and then give it the news category, like that. So we're crawling politics, business, health, science, and things like that. And what we want to do is we want to also have the articles crawled. So articles crawled is equal to 0. This is just the number of articles that we crawled, and we are going to break once we reach our limit, which is 100. So for article text in get next article, again, if you remember, this is an iterator function, and we can just call it to get the next article. What we want to do is we want to increment the articles crawled, and we want to have the data.append, and let's initialize the data first. So data is going to be a list, just a list with all the articles and their categories. So data.append, and it's going to append a dictionary that is going to have the news category, which is the news category right there. And it's going to have the article as well. And the article here is going to be the article text. So right now we have the label, which is the news category, and the text itself. Now this is going to be our label data set that we are going to train our news classifier on. And yeah, this is how you formulate a structured data set for our use case. Now in this format, in this like list and a dictionary format inside. This can be converted quite easily to a pandas data frame, which can be simply exported to a CSV file, to an Excel file, whatever you want. The last thing that we want to do is that we want to break. So if article right now, if article crawled is greater than or equal to 100, then we break. And we can just run it, make sure that everything is working good. And yeah, right now it's crawling articles 1, 2, 3, 4, 5. It will continue on crawling till it finishes all the data. And when it finishes it, we are going to basically put it in a pandas data frame and export it as a CSV file. So it's going to take a little bit of a while, so I'm going to pause the video and then return back when it's done. So when it's done and it finishes processing everything, feel free to delete all the other cells like those. So just clean things up. And then we can import pandas, which is a library that helps us process any structured data. So import pandas as PD. You can go back here, PD dot data frame, and give it data, and make it as a df like this. And you can also save it. So df.csv, and let's call it news articles dataset.csv, and set the index equal false because we don't want to have an index column basically, which is going to be from 0 to whatever number of rows that we have. And yeah, this is how you save it as a CSV. Now you won't find anything here until you refresh it, so make sure to refresh it, and you're gonna find the news articles right there. You can download this dataset by just clicking on those 3 points and pressing download. Now make sure to download this dataset so that if anything crashes, if anything goes wrong, you don't have to crawl this again, and you don't have to lose some credits with Decodo. So just download it, make sure that everything is good, and then you can find it locally. So go to your downloads folder, and you're gonna find that there's a news article right there, and the article itself. There's a lot more text here, but the Excel is not showing it. But you can we'll read it right now and make sure that everything is good. Go back again to your Colab, and then we can start off by reading the dataset and understanding it a little bit. So we can read the dataset quite simply with df is equal to pd.read csv. Give it the news articles category dataset, which is this the same name .csv. And you can have a head. Head basically shows the first 5 rows of it. So you can see that there's news category, and there's the article itself in text, and you can also have sample and tell it to show 5 rows. This is sampling 5 rows at random. So politics, climate, business, science, and climate again. It shows different basically text for each one and different articles for each one, and you can just sample it again. And yeah, everything here now looks good. This is all the data that we are going to need to fine-tune an LLM. So in the next section, I'm going to explain what LLMs are and what is training an LLM and what is fine-tuning an LLM. And we are going to cover a lot of the basics right here. It's going to make the code way more understandable if you stick through it. So it's only going to be 10 minutes. It's going to onboard you on a lot of the basics. And if you have the basics of training the models and training LLMs and what are LLMs, feel free to skip this section and then come back again to your code. A large language model is a mathematical function that predicts what word comes next in any piece of text. For example, if I provide the input, I am going to the The model might predict supermarket as a potential next word. LLMs can also generate full sentences by iteratively appending each predicted word to the input and then predicting the next word again. This process continues until the model determines that the sentence is complete or reaches a specified length. For example, if I provide the input, "What's the capital of France?" the model will predict the answer one word at a time. The first word it predicts is "the," which is then appended to the input. Using the updated input, the model predicts the next word, capital, and appends it to the input as well. This process repeats with each predicted word being added to the input until the model completes the answer or reaches its maximum allowed length. In this case, the final answer is "the capital of France is Paris." All the words that the model can generate or read are a part of its vocabulary. A vocabulary is a collection of words built from all the text that the model learned from. But human language often involves words that can have many variations, like adding suffixes, prefixes, or changing tenses. This can result in a large number of very similar entries in the vocabulary, since each variation of the word might be treated as a separate entry. For example, break, breakable, and unbreakable could all end up as individual words in the vocabulary, even though they have common parts. As humans, we can understand the word unbreakable even if we didn't see it before. We can break it down into smaller parts, un, break, and able, and from here we understand the word. Now, LLMs pre-process text in a similar way through a process called tokenization. Tokenization splits sentences into words or subwords called tokens. Each token is assigned a unique ID or number, and this information is stored in the model's vocabulary. The vocabulary is created from all the text the model will learn from. This means the words and subwords in the vocabulary came directly from the training dataset. The training dataset is usually billions of text samples from the internet, like books, articles, posts, and more. Preparing this vocabulary is an important first step before the model can start learning how to generate and understand language. The model's learning process is called training. During training, the model goes through each text sample in the dataset, randomly masking or hiding one or more words. The incomplete sentence is then given to the LLM, which is tasked with guessing the missing words. Initially, the model might make random guesses, but over time, it improves through a process called backpropagation. Backpropagation is the process a model uses to improve its predictions over time. It starts by checking how wrong the model's guess was. This is called error. Once the error is calculated, the model adjusts its parameters slightly to reduce this error and make better predictions. As mentioned earlier, a model is essentially a large mathematical function that takes input and produces output. The adjustable parts of this function are known as parameters or weights. They determine how the model processes information and produces output. We'll circle back to them later on. Trying to predict missing words or next words in a sentence is called causal language modeling. It enables LLMs to understand and generate text, but it might often lack the ability to respond accurately to specific tasks and questions or follow detailed instructions out of the box. In this example, instead of responding to the question, the model generated a list of similar questions as its output. The training dataset might have had groups of questions like that, so it's generating a similar structure. To help the model respond to input questions and tasks, we use a process called instruction tuning. This step comes after the causal language modeling and builds on top of the trained model. Just like the previous training, we are trying to also predict missing or next words in the text, but this time the dataset is more specific, containing only examples of questions or tasks and their answers. This dataset is more focused, often containing fewer samples than the general LLM training dataset. While it's sufficient for teaching the model how to respond to tasks or questions, it doesn't provide enough language data for the model to learn general language patterns. That's why causal language training is done first and instruction tuning follows to refine the model's ability to handle tasks effectively. Instruction tuning is one way we can fine-tune a model. Fine-tuning is where we take a large model that already has been trained on a massive dataset and teach it how to perform a new task by showing it examples. These models already understand a lot. They've learned grammar, vocabulary, reasoning patterns, and general knowledge. So instead of starting from scratch, we only need to give them a smaller, task-specific dataset to nudge them in the right direction. Think of it like teaching a smart assistant how to do something new. You don't need to start from the alphabet, just explain the task. Training the initial model usually takes days to finish on very powerful machines because it's trained on billions of samples. But fine-tuning uses thousands of samples and can be trained on only the last layer or a couple of layers and not the full model. In this case, we're going to fine-tune an LLM to act as a classifier instead of its usual role as a text generator. That means instead of generating full sentences or paragraphs, we want the model to output a class label. To do this, we keep most of the model intact, all its layers, weights, and learned knowledge, but we swap out the final layer, the one that usually predicts the vocabulary tokens. We replace it with a new layer that predicts class IDs. This kind of modification is sometimes referred to as adding a model head or a model cap because it's like attaching a new head on top of the existing brain to focus on a new task. We can also only train the newly added layer, making our training faster and more efficient. So with just a small amount of data and a simple change to the model, we can teach the model to perform a completely new task, leveraging all its existing power to get great results with minimal additional training. Let's take a step back and dive into how the model learns. Let's use a very simple example to understand this. Imagine we're training a model to classify animals as either dogs or cats based on their height. As we mentioned earlier, a model is a mathematical function, and in this example, we'll use a simple equation y equal mx plus b. This line helps the model decide. Anything above the line is a dog, and anything below the line is a cat. In this example, the model has two key adjustable parts called parameters or weights, which are m and b. These parameters control how the line is drawn. For instance, if we set m equal 1 and b equal 1, the model will draw this line. However, at the beginning, the model doesn't know the best values for its weights, so it starts with random guesses. The model then calculates its error by checking how many animals were classified incorrectly. These mistakes are shown in red. Now the model can adjust m and b slightly to make fewer mistakes using a branch of mathematics called calculus. The model repeats this cycle over and over, improving a little bit each time. By gradually tweaking the parameters, it learns from its mistakes. Eventually, it becomes good at separating dogs and cats based on height. This step-by-step improvement is how the model learns or trains. As the model learns, it adjusts its parameters to better classify the data. In our simple example, there were only two parameters, m and b, which meant that the model could only draw a straight line to separate dogs and cats. But real-world problems are far more complex, and a simple line isn't enough. The more parameters or weights a model has, the more flexible and intelligent it becomes, allowing it to capture intricate patterns in the data and making smarter predictions. More weights mean better accuracy, but it also means that it will be slower to process and will require more computational resources and cost to run. So it's a trade-off between cost and speed versus accuracy. To handle even more complex tasks, models organize these parameters into layers. This is how the previous equation can be represented in a layer diagram. It has one input layer and one output layer, but the bigger models has more layers in between called hidden layers. Each layer processes the data in different ways, with the output of one layer becoming the input for the next, allowing the model to capture increasingly intricate patterns. So now that we understood a lot about what LLMs are and what is training and fine-tuning, we can go ahead and train our own classifier model. Before we start, I want to walk you through the steps required to fine-tune an LLM. I'll create a text cell right there to just write it down. And just steps to fine-tune an LLM. So right now, basically our first step here is to define a couple of parameters like this, and right here we'll define just maybe the dataset path, which is this one. We'll define how much data that we are going to allocate for testing and how much data that we are going to allocate for training. We're going to also define the column names that have the label and the column names that have the text. So all useful parameters that we are going to use on later on in the code. It's going to be easier for us to put it right at the top so that we can easily see all the parameters and fine-tune them later. We'll also read in the dataset because right now we're saving here the dataset and sometimes we need to switch from GPU to CPU, and yeah, we can just read in the dataset, make sure that we read it. So the second step is clean the dataset. Our dataset is fairly cleaned, but in some scenarios you can find some HTML code inside of the text. You can find that the text has some weird symbols, and when crawling the dataset you can find a lot of things that are added to the text that we can remove, and this is what cleaning the dataset is. And maybe we can remove the nulls, we can remove the rows that was without any labels. Again, I'll show you how we do this, but I think our dataset is clean enough so that we don't actually need it. But it's good to also follow along the process so that if you do it with any other dataset, it's going to be a process that you follow. The third step is going to be wrangling the dataset. Wrangling the dataset means that we are going to put the data into a format where the trainer or the Hugging Face trainer can actually use this data. So we are going to be using, again, Hugging Face in this tutorial, and Hugging Face is a library that is going to help us load the model, train the model, and do all sorts of functions on it, and it has a lot of convenient functions to use. And it's also called the Transformers library, so I'm going to be using both terms interchangeably, Hugging Face and Transformers. And the first step is to have a label encoder. Basically, our labels right now are in text like politics, climate, science, business, things like that. We need to have them as indices from 0 to 5. And one of the ways that we can do that is to use a label encoder from sklearn. You can also assign it manually, but label encoder is best practice and it expands quite well so that if you used it with any other number of labels, it will work quite good. So the second step is dividing the dataset into training and testing. So we can train on a group of rows and test it on another. And this is going to help us evaluate our model since the model didn't see the testing samples before. And the third step is going to be converting this dataset from pandas to a Hugging Face dataset. And this is again going to help us feed it through the Hugging Face trainer. And the fourth step is going to be initializing the tokenizer. Just as explained before, tokenization is the process of moving the words or subwords from letters to being numbers, basically. And this is going to be the input for the model. The fourth step is going to be initializing the model. Now, initializing the model here means that we are going to pull it from Hugging Face, the Hugging Face model hub, and then we are going to load it into memory and prepare it to be trained. The fifth step is going to be training the model, and we are going to be defining a couple of training parameters and then call the train functions on it, and then we wait for it to finish training and learning from the data. Step number 6 is going to be evaluating the model. Now, this is going to measure the accuracy levels on the training dataset and the testing dataset to see how accurate our model is. Now, step number 7 is going to be model inference. Now, step number 7 is going to be model inference. It's after we trained and saved our model, then we need to load it and use it as the step number 7 is going to be model inference, and after training the model and saving it, we load the model right here, and then we use it as if we're going to use it in production, where we give it text and expect from it a label. And this is it. This is just going to be the end-to-end workflow of fine-tuning an LLM. So we're going to be coding this step by step. So yeah, follow along. And when you have the big picture, I think it's going to be easier for you to understand the code. So one of the libraries that has a lot of open source LLMs that we can use out of the box, and it also gives us the ability to train and fine tune them quite easily, is called Hugging Face. So go back to your browser right now, write huggingface.co, and you're going to see this website. If you pressed on models, you're going to see a lot of models. You're going to see computer vision models. You're going to see natural language processing models, and you can see whatever you want. For example, one of the models that are very popular right now is called DeepSeek, and you can just write DeepSeek right there, and you're gonna see that it's here with 671 billion parameters. It's not gonna be fitting in the Google Colab. In Google Colab, we have just 16, almost like 15, 16 gigabytes of GPU RAM. So we'll just respect that. But just know, if you have enough resources, you can train your own DeepSeek model, you can train your own LLaMA models, and you have a lot of awesome models out there that is open source and you can fine tune quite easily. So you can go here to LLaMA, and you can press on this LLaMA 3.21 billion parameters, but we don't want to be instruct tuned. We want the normal one. So basically, go back to go LLaMA right there, huggingface.co LLaMA. If you scroll down, you're gonna find a lot of models. So you just keep searching for the 3.11 billion parameters without the instruct tuned. And this is it. This is the model that we are going to use. Now, to use this model, I'm going to show you how easy it is to choose a model over another. But basically, like you can choose any model by just copy pasting this ID of it. So LLaMA 3.2. And if you wanted to choose, for example, DeepSeek, and you have enough resources, you can just write here DeepSeek, and you can just copy paste this. And everything else, every code that I'm going to write is going to stay the same. Just you change the ID and everything stays the same, and it's going to work beautifully. So right now you can see that I have access to this model, and if you don't, you just create an account with Hugging Face. It's totally free, and I'm going to show you how it's going to look like if you don't have this access. So just have this, and yeah, make sure to sign up or log in first, and then when you log in, you're gonna find here a button that is telling you like grant me access or something like that. Just press on it, and it usually takes like 5 to 10 minutes to grant you access. So yeah, you can just go make yourself a cup of tea and then come back, and it should be ready for access. So when you see this granted model, you have been granted access to the model, then you can just start using it. Now because this exact model has access access rights, it needs to understand in the code that this is you. This is actually you that is being trying to access the model that you have been granted access to. So to do this, you're gonna need to get the token for your account that tells that this is you. So go back here to your account, press it, and then edit profile, and then go to access tokens, and then you can write your password to verify that it's you. And then you can just create a new access token for yourself. Just press on this create new token, just make it a read, and then right here LLaMA token tutorial, or like whatever you want. Just it doesn't matter the name, to just create token, copy it, make sure to get your own token. I'm going to invalidate this token after the tutorial. So yeah, just put it here as Hugging Face token and paste it in. We also want to paste in the name of the model. So go back here, and you're gonna find the LLaMA model. So again, LLaMA, this one, and just copy this, and this is going to be the name of the model that we are going to use. Again, if you want to choose any other model, feel free to do so, but this is the model that I'm going to use right now. So model name is going to be LLaMA 3.2 on only 1 billion parameters. Again, I'm choosing a smaller model here because the RAM here is 15 gigabytes, but if you have more RAM, then actually specifically GPU RAM, then feel free to increase this. Now, let's structure our code right now, and let's define our parameters. So this is going to be parameters and reading data. And we are going to import pandas as PD, import Hugging Face, a Hugging Face hub. And this is going to help us log in with our token so that LLaMA knows that this is actually us trying to access the model, and we have been granted access already. And we can have the dataset CSV path. And this CSV path is going to be this path above, but instead of just hard coding it, I'm just putting it into a variable so that it can be easy for you to change if you want. We can have the text column. Again, this text column is going to be the article, the column that has the text. So text column name is going to be article. Then the label column name is going to be the news category. Then we are going to dedicate a portion of this dataset to testing, and it's going to be 20%. So test size is going to be 0.2, which is equal to 20%. Then the number of labels, and this is the number of categories that we have. We have right now 5, and you can put a default of 2. So default of 2. And then I can get the number of unique categories right there. So basically, you can have the news category dot, to get the number of unique, you just write n unique, and it's going to tell you how much unique categories you have in this news category. So you can just overwrite the number of labels right there, like this. And yeah, you can just do that, make sure that everything looks clean, and yeah, we can proceed from here. Now, before we do anything else, we just want to log in with the Hugging Face token. So Hugging Face hub dot log in, and give it the Hugging Face token and run it. Make sure to import the Hugging Face hub and then run it again. Make sure to initialize, the parameters, and now the Hugging Face hub is already logged in. Now we have read the dataset that is here, and we already and we defined a lot of parameters up above. Now the next step is to clean the data. Now this data right here, if you see it, it's going to be clean. The text is clean. So if you open the article and actually like sample dot sample of article of iloc of 0 means get the position of 0 of article, you're gonna find that the text is somehow clean and it doesn't need any cleaning. But I want to also show you the whole process, because not a lot of text that you can crawl from the internet is clean, and you will need to also create a cleaner. So I want to show you how you can create this cleaner and how you can add functions to it so that you can be able to expand this to other projects as well. So step 2 is going to be clean data. Again, we don't need cleaning data here, but it's just for learning purposes. So from BS4 import beautiful soup. One of the cleaning things that we want to do is we want to make sure that there is no HTML tags at all in the text. So we can create a new class. Let's call it cleaner. And inside of this cleaner, we will have an init file. that does basically nothing right now because it's a simple cleaner. And then we can have a clean function, and this clean function takes in the text and then basically runs a lot of cleaning functions and then returns the clean text. So one of the functions that we want to write is remove any HTML tags. So remove HTML tags like this, self.text clean text is going to be equal to the beautiful soup. Beautiful soup text.html HTML parser, and you can also write LXML parser, and you can just get the text. So you can have the text like this, and you can return the clean text. So if there's any tags we want to exclude it, Beautiful Soup is going to exclude it for us, and then we can just here have the clean text. So we can have this like the clean text, which is self.remove HTML tags, text, clean text, and then it returns back the text. Let's say we also have some double spaces, like this is a space, but for example, let's say that we have something like this. We have double spaces all over the place, so we want to also clean that. So what we want to do is we want to remove double spaces, and it takes in the self, takes in the text. Again, we don't have this, but I want to show you how you can do it. So you can do this by a library called re. So just import it, and this is how you do it. So in here you can just write clean text self.remove double spaces. You can run it and you can have it back. So this is how you can have a cleaner. You can have as much functions as you want and call them in whatever order that you want it. And this is it basically. So just run it. Then we can initialize it. And then we can have the df.text cleaned. And it's going to be defined of the data frame of the text column, and to run a function on all the columns that we want, we can use something called the apply function, and it will just run the clean function, which is this one, on all the rows that we have on the text column. So this is going to run this clean function in all the text column and save it in the text clean column. Basically, I forgot here a self, so just add it right there, run it again, and everything here should be good. So you just have the head. You now have the text clean column, and this has the text, but it is cleaned. And yeah, we can move on from here. The second thing that we want to have is that we want to wrangle the data. Basically, the model expects us to have, instead of news categories like this, politics and things like that, it expects us to have numbers. So from 0 to whatever maximum number of labels that we have 5. So we want to convert this from being words to being label IDs. So let's now have the cleaner data. So let's the third thing that we want to do is wrangle data. Again, I'm showing you here the steps so that you can follow along and you can train whatever model that you want. So you read the data, you clean it, and then you wrangle it. This is the basic process of training any NLP model. So right now, we just want to have a label encoder that encodes those labels to numbers. So we can have label encoder like this, and from sklearn import processing. It's pre-processing like this. And we can define the preprocessor like this. So you can have the label encoder, LE, which is the preprocessing of label encoder. Then we want to have it to fit. So LE dot fit, and fit will take in the define of label column name dot toList. And after that, we want to just transform and put the transformed to the label column. And right here, we also want to make it to a list. So this is going to put the labels, the numerical labels in the label column. So you can just make a head out of it. So you can see that politics is label 3. And if you sample it, you're going to find that business is label 0 and health is label 2, so on and so forth. You will have 5 labels. After that, after doing the labels, we want to split the data between training and testing so that we don't use the whole data set for training. We want to test it and see the accuracy of it as well. So after that, we want to have a train test split. So a train test split like this. And we can easily train and test split it using sklearn. So from sklearn.model selection train test split, we want to import it. We already have the test size, so we can just have the df train and df test. And we are going to have the train test split of df. We are going to give it the whole data frame, and we are going to give it the test size. And yeah, this is it. Train test split also shuffles the data, so we don't have to worry about that. So you can just run it, and we can see the output of it. So you can have the df train. You can see that it has science, health, climate, and things like that. We have the df test dot head, the same thing as well. We want to also see the shapes of it, so how many rows each one has. So shape and df test of shape. So you can see that for training we have 400 samples, and for testing we have 100 samples. And everything here is looking good. We can now also take just the text cleaned and the label. So df train of text cleaned and label. And the same thing we are going to do for df test. So just do that. We are just taking 2 columns to make it easier for us and easy for us to understand. And then, yeah, that is it. The next step is going to be converting this pandas data frame to a Hugging Face dataset so that we'll be able to feed it to the Hugging Face library and to train on it. So let's do this step next. So this step is going to be convert to Hugging Face dataset. And in order for us to use the Hugging Face datasets, we need to pip install it. So you can go back up again, and we can make a new section called install requirements. So in here, make a new section right there called install requirements. And in here, we can pip install datasets. And while we're at it, we can also install a library for evaluation. So we can also pip install evaluate. And those are 2 libraries that we are going to need to basically convert the dataset to the Hugging Face dataset format. And then after training, we need to evaluate our model. So we are going to be using the other one as well. And right here, before we start crawling, we can have a section called crawl data. So let's run it and see how it goes. So now it's finished, and sometimes it requires us to restart the kernel so that it can work. It can be imported, but we'll see here. We'll just try to import it, and if it doesn't work, we'll restart our kernel. So in here, just in case, you just have to runtime restart session, and then you'll need to run all the above cells. Again, don't run your crawler. You have the dataset already saved on your device, so you can just upload it using this button. So upload, press the upload button, press the thing, and you don't need to crawl your dataset again. So in here, you can just have from datasets, import dataset. See if it's imported. So it's importing good. So train dataset is going to be dataset from pandas and give it the df train. We are going to do the same thing for the df test. So the final part of wrangling the data is tokenizing the text. So as you remember when I was explaining, the model takes in the words as numbers, and it does that by tokenizing it or mapping the words to the index IDs for its vocabulary. And we are going to do the same thing right there. And we are going to use the Hugging Face library for it. So you don't need to write anything manual. So right here, you can write tokenizer, and from transformers, import auto tokenizer, and the tokenizer right there is going to be auto tokenizer from model, and you give it the model name, and this will load the tokenizer of the model that we specified above, which is the LLaMA model. And then we are going to specify the padding token. And the padding token is just a token that is put at the end of the text when they are not in the same length in training, so that they can fit into the GPU and be optimal. So this padding token does not have to be specified for every model, but for LLaMA it does. So you can just specify the padding token as the tokenizer of end of sentence token. So at the end of each sentence, there's a token that indicates the end of sentence. So we can just use the same token for the padding token. The same thing we are going to do for the padding token ID, just to be explicit about it. So padding token ID is equal to the end of token ID, and then we can run it. Now that we have the tokenizer ready, we can now create a function to tokenize text. So define pre-process function that is going to tokenize the text. So it takes in the examples, it returns back the tokenized text. So return tokenizer of examples of text cleaned, which is the column that has the text that we want to tokenize, and we are going to truncate equal to true. If something is out of the bounds of the LLMs, because LLMs has a maximum number of tokens, if something exceeds this maximum number, we just truncate it, we just remove anything that is above the maximum. And this is how you tokenize the text. And let's now tokenize our training data. So tokenized train is equal to train dataset.map, and then give it the preprocess function, tell it to batch it, to put it into batches, and then we are going to do the same thing for the df test and put it as a tokenized test. So just run both and wait for them a little bit for them to finish. And now they are done. So the fourth step right there is going to be initializing the model. So the fourth step is initialize the model. In here, we are going to also use the transformers package. The transformers package is the same thing as the Hugging Face library that I showed you. It's the same thing at the end of the day, it just has a different name. So it's the from transformers import auto model for sequence classification, because we want to do sequence classification. Then what we want to do is we want to initialize the model. So in here we can have the model is equal to auto model for sequence classification from pre-trained, and then I give it the model name, and then I give it the number of labels. So I just run that. It will take some time to run and load the whole model into memory. So now that this is done, we also want to specify the padding token the same way that we did for the tokenizer. So model.config .pad token ID equal to the model config.end of sentence token ID. We just want to have this, and we also want to have a concept called freezing layers. So like I was explaining, fine-tuning doesn't necessarily need to train the whole model. It can only focus on the classification layer that we're adding, or maybe a couple of layers before that. So we don't have to train the whole model. And here the layers that we don't want to train is called freezing layers. So let's first understand how many layers that we have in LLaMA. So we can have layer number is equal to 0, and for param in model dot base model dot parameters. So we want to have the number of layers, so number of layers like this, and it's going to be plus equals 1 with each layer, and at the end of the day we want to just print it out. So number of layers is going to be equal to the number of layers. So we have 146 layers in this small LLaMA model, and we can just freeze everything up until the maybe last 20 layers or 25 layers. So we can just copy paste this, put it here, and a layer number like this. And basically what I want to do is that if layer number is greater than or equal number of layers, which is this one, which has the 146 minus 25. So if it's like the last if it's the last 25 layers, then we don't freeze them. Otherwise, we freeze those layers. So otherwise here we have the params dot requires grad is equal to false. So basically this basically freezes layers, like requires grad is equal to false, meaning that it won't calculate the gradients for this layer, and it will not calculate it from 0 till the last 25 layers. So the last 25 layers will be learnable, but anything before that it will not. Now this is also tunable, and the more layers that you add, the more accuracy that you're gonna get, but the more time that you're gonna spend training, and also the more resources that you're gonna need. So make sure to also balance between those, the resources and the accuracy. So right now I'm going to only choose the 25, and yes, I am going to continue from here. Now the fifth step here is to train the model. So in here we can have a 5 train model, and training the model will also use the transformers library, and we'll use the model that we loaded above, and we'll use the data that we also prepared above. So from transformers import training arguments and trainer. And we also want to import from transformers, we want to import the data collateral with padding, and we also want to import evaluate, and we also want to import numpy as NP, sorry. And numpy is just a matrix library that is going to help us do some calculations while evaluating the model accuracy, basically. So data collateral is going to help us feed the data to the model. So we can initialize it first. So data collateral like this is going to be the data collateral with padding and give it the tokenizer. We also want to define the metric that we are going to use to evaluate the model. And we are going to evaluate the model with accuracy. So evaluate dot load and give it the accuracy. Like this. And then we want to have a function to compute the metric, which is accuracy. So define.compute metric, we just have the basically the output of the model. We get the maximum basically predicted class of the model, and then we can compute the accuracy by just calling the metric.compute and then giving it the predictions and the labels. So this is how you can calculate the accuracy. And then we are going to be defining some training arguments and then call the trainer, like initialize the trainer first and then call the trainer, and we are going to be almost done with it. So training args is equal to training arguments. And we are going to have our checkpoint stored in the results folder. And then we can delete all that. We can fill them one by one. So we have per device eval batch and training batch. So per device training batch. We are going to make it only 2 samples at a time. And this is the amount of samples that we train concurrently together, and the more it is, the less time that we are going to take in training, but the more resources it takes. And 2 is the absolute maximum that Colab can take right now, so I'm just putting 2 right now. Then we have report to none. Basically the training, basically while training, you're going to find a lot of good numbers, statistics, accuracy levels, loss functions, things like that that can be very useful to trace. And there are multiple tools for us to trace it by, and we are not going to use any right now. We're just going to use the numbers that is outputted to the console. So that is it. And we are going to also use fp16 is equal to true, and this is going to also help us with resources a little bit, so that the floating point is going to be only 16 numbers, and the more numbers it's going to take, the more memory it's going to consume. So just putting it at fp16 is going to help us to put it into memory. Then we are going to set the learning rate, and the learning rate is the how much a model is able to change its weights based on one learning step. So this is usually a very small number, so I'm going to put 2e-4, and I am also going to have the weight decay. That is going to help us not to overfit, and then I am going to also have the save steps every 2000 steps. So basically right now what I'm saying is that every 2000 steps you can save the results back to the results folder, and the default was 500, and it's too much for our use case, and it might make the Colab go out of memory. So I increased it a little bit, and it won't hurt us a lot. It won't hurt us at all, actually. So the next step is to define the trainer. So trainer is equal to trainer, and we are going to give it the model, the training arguments, the training dataset, the testing dataset, the tokenizer, then the data collateral that we defined above, And then we can have the compute metrics and it's equal to the compute metrics functions that we had above. And the data collator, maybe I just make sure that I'm spelling it correctly. Yes, I am. And yeah, this is it. This is how you can define the training arguments and the trainer. And to train, we just run the trainer.train. Now, right now we are not on a GPU machine, so it might break or it might even take a long time. I just want to make sure that it will start training. And if it is, I am going to close it. And before closing, just make sure again to download the news article dataset CSV locally so that we can import it quite easily after reloading this notebook. So it's taking a long time, so you can just close it right there. And you can just change the runtime. So just press on runtime, change runtime type, press on the T4 GPU, press save, go back again to the go back again up here, install the requirements. Do not crawl the dataset again. You have the dataset crawled, so you can just upload it. So you can press here, upload news article dataset. It's being uploaded, so just wait for it a little bit to finish. And to run everything underneath this cell, you can just press runtime and then run cell and below. So you just, it will run all the cells and below. You can scroll down to your trainer, wait for it to start training, and then we can pause the video and come after it trains. So the one thing that I forgot to specify is the number of epochs. So the number of epochs is the amount of times that you loop over the dataset and learn from it. So number of train epochs, and we can make it to 5, but I think like you can just make it to 100, 50, something like that. And yeah, it's by default 3, so we can keep it as 3 right now. And yeah, don't forget that if you're training on a larger data set, if you want to get more accuracy, you just increase this number to learn more and more. And yeah, this is it. So we're going to wait a little bit for it to finish. It's going to take here 3 minutes, but if you have like 50 or something like that, it's going to take more. So we're going to wait for it to finish, and then I will continue from there. So the training is now done. I feel that we need to train more. The loss is still high. So what I'm going to do is that I am going to train for 5 more epochs. So just train it right there. It will continue training, so don't think that it's going to train from scratch. So yeah, basically you can make it train for 5 more epochs or 10 more epochs, and yeah, just make it 10 more epochs, and then we can come back later on. So it will continue here training on, and we'll come back later. Now that the training is done, it's time to evaluate our model. So step 6 is going to be evaluating our model. So evaluate model. And we are going to use an sklearn function for that. So it's going to be from sklearn.metrics import classification report. Then we are going to get the predictions of, we are going to evaluate both the training and the testing. So let's start with the training. So equal trainer.predict, and then we are going to predict on the train first. Then we are going to take the preds and np.argmax predictions of, and it's going to be like this. everything till the 3 and then of 0. So if you basically looked at the predictions, let's look at the predictions first, and then we can continue from here so that you can understand what is this -3 and then of 0. So it's taking a little bit of time because it's running on 400 samples, but it should be done soon. While that is running, you can see that the results here have some checkpoints, which is the 2000 checkpoint, the 600 checkpoint. And yeah, if you refreshed it, you might find more, but this is the checkpoints that I was telling you about. And the trainer right now trained it, and we can actually save the trainer, but let's evaluate the model first, and then I'll show you how you can save the trainer and then how you can import it and use it as a classifier quite easily. So you can see here in the preds, we have the predictions, we have the label IDs, we have the metrics, and choosing only the first 3 like this will get you the array, the output of it, and the training loss. And then choosing of 0, this chooses the logits of each class. So this is the first one, and we are going to choose the maximum number, which is going to be index number 1. So basically this is it. And if you chose this, so basically here it's telling you that this is index number 1, so you can actually choose index number like this is index number 0, this is index number 1. So you can choose actually index number 1 and don't do the argmax. So you can do it whatever you want. So it's basically telling you the same thing. So it's right here, and it's also telling you the accuracy a little bit. So it's 0.85, which is 85%. So in here you can have the NP. I just want to also show you the argmax because it's going to be utilized a lot in other things. So argmax basically tells you that what is the argument that have the maximum number, and axis equal 1 basically tells you that run it here 1 row at a time. So axis equal 1, and it's going to tell you this. So this is the predictions. So you can just comment this so that it can be done. And the what we want to do now is we want to get the ground truth. The ground truth of it is going to be df train of label, and we are going, this is the label column, and we are going to make it .toList like this. And the last thing is that we are going to print out the classification report given the ground truth and the preds. Again, we don't need to run the prediction again, so I'm going to comment it here. And in here, it's because I overwrote it before. And yeah, you can just now run it. We'll have to wait this minute again, unfortunately. But yeah. Afterwards, you can get the classification report. For the same thing, we can have the testing accuracy. So just copy and paste it right there. And instead of train, just write test. And instead of using the df train, use the df test and also run it so that you can have the training and testing accuracies. So now it's done, and you can see the accuracy level is 85%, and for the testing accuracy it is 50%. Again, we're not using a lot of data, and fine-tuning usually happens with thousands of data points, and we only did this with 100. So this is awesome accuracy given that we are using only 100 data points. So yeah, with that being with that done, we just want to now save the model and then also utilize it for inference. So in here we can save the model by having the model.config.id to label. Basically what I want is that it's outputting 0, 1, 2, 3. I want to tell it that ID 0 is, for example, politics or business or whatever. So in here, if you remember, we used a label encoder, and it has something called classes, and classes is like this, where 0 is business, 1 is climate, 2 is health, things like that. So I can have the ID to label, and I can have this as I label for I and label in enumerate, and enumerate just puts the index with the class. So it's basically going to put 0 with business, 1 with climate. It depends on the index of the array. So this is ID to label. We also want to have label to ID, and it's going to be the same thing, but I'm going to just swap it, label and ID like this. And yeah, this is how you do it. Then in order for us to save the model, we just run trainer dot trainer like this dot save model and give it the model directory. We are going to call it news classifier like this model. We can also have the tokenizer also saved. So tokenizer dot save pre-trained and give it also the same folder. And just to make it specific, we are going to have this dot slash, which says this is in the same folder, and we are going to run it. It might take a little bit of time, like a minute or two, so let it run. And right now it created the news classifier model. So yeah, just wait for it to run and then we can continue. So now that this is done, you can see that this is the output right here, and you can see the news classifier right there. And you can also save it to your Hugging Face hub. So this is how you do it, and this is how to save in Hugging Face hub. I am not going to do it, but it's basically going to create a new entry for you on the Hugging Face hub, and you can take it from there. But make sure when you do that, your token above is going to be read and write. So right now it was only in read. So when you're doing your token, make sure that it's right so that you can push it there. Now the final step is going to be model inference. So right here we can have 7, which is model inference, and in model inference we are also going to use the transformers library, transformers, and import pipeline. And in here we are going to create a classifier model that is going to be the pipeline of text classification. Model is going to be equal to the model right there. And if you want to push it, like if you pushed it on GitHub on Hugging Face hub, you can just copy paste the model ID like I showed you with LLaMA, and then the tokenizer is also going to be the same thing. So tokenizer is going to be the same thing right there. And yeah, it's by default it's going to load in the CPU. So if you want to load it into the GPU, make sure that you have the device is equal to 0. But I will leave it as CPU for now because we're going to only test on one article. So just have this, run it a little bit. So now it's done, and we can go get an example article. So go here to NPR, go for example into health, and let's choose something that is health related like this. So we don't need to copy all the article, we just need to copy a little bit of it. So just copy it, go back here, and make sure to have the example article. And I am going to put it as normal text like this, and I'm going to run it, and I am going to have the result of it is going to be CLF of example text, and then print out the result. So you can see that it predicted that this is health with a score of 0.83. So before we close, I want to show you how we can get better accuracy levels by increasing the data sets. So just in the crawling script that we wrote above, instead of making it 100, I just made it 1,000. And I just have this print statement every 100 articles. So we don't have too much prints in our notebook. So this is basically it to crawl 1,000 articles per category, and I am going to link this news article dataset with 1,000 articles per category in the description below, so you can also use it. And then you can just run everything else the same. So one more thing to note is that I want to also show you how you can use Hugging Face to push your model to the Hugging Face hub. So go back to your Hugging Face and edit your profile. Press your access tokens. Make sure to create a new token with write access, so you can write whatever you want. So LLaMA tutorial, and you can just create a new one, copy it, and you can come back to your notebook and paste it here in the Hugging Face token. So yeah, I already did that. So right here it's going to log you in, and it's going to give you access to write to the Hugging Face hub. So everything else stayed the same. So you can scroll down, and everything else, you just run it again. I just run this trainer for 10 epochs, and the loss is still going down. So actually running it for more epochs will give you more accuracy. And right here it saves local, but right here it saves to the Hugging Face hub. And I added this line, model.push to hub. I wrote the trainer and the tokenizer, but I forgot the model, so don't forget that. And right now, when you just run this, when you train the model and go back to your Hugging Face and press to your profile, you're going to find the news classifier model. So you can just pull it from anywhere you want. You don't have to save it locally. You don't have to drag it around. So you can just pull it from the Hugging Face hub, just like we pulled in the LLaMA model, like that, just like that. And yeah, it just installs it and downloads it from the Hugging Face hub. So that's a very convenient place to keep your models. And yeah, I just also wanted to show you how you can do that. And right after that, you can see that the training accuracy is 76%, but you can see that the testing accuracy right now is 73%, which is way better than our 50% accuracy levels. And again, this can be way better if we can just run it for 20 epochs, and this is just 1,000 articles per category. And right at the end, I want to also show you how you can load a model that is not local on the Hugging Face hub. So right now you can just open this, and you can copy its name and paste it in the model, like here, and paste it in the tokenizer. And when you do, it will just automatically load it from whatever place you want, and it doesn't have to be local. And when you test it out, this is going to be also health. So basically that's it. You learned how to crawl a custom dataset from the internet, you learned about LLMs, and you learned how to fine-tune them on a classifier task. So hopefully you learned a lot from this tutorial, and yeah, see you in the next one. Bye.